Back in 2010, 20 major airports were shut down and 10 million passengers were affected when the Eyjafjallajökull volcano, I think that's right, in Iceland spewed ash up into the sky. Anyway, I've got to go. It's my own volcano chasing time. Japan, a hotbed of seismic activity. Of the 1,500 active volcanoes in the world, 110 are here in Japan, and that is what I'm here to see. Really hoping that Sakurajima volcano gives us a good explosion. There's someone I want to introduce you to, and he's invited me here to a Japanese hot spring foot bath to really experience the heat, the geothermal battle that's going on underneath us. This is Dr. Corrado Cimarelli.
Hi, Greg.
He knows a lot about volcanoes, and his research, supported by AXA, is looking into a very sticky problem: how volcanic ash can be so dangerous. So, Corrado, hopefully Sakurajima volcano is going to erupt for us. What's going on in there at the moment?
So, when the magma rises up into the crust and approaches the volcano, the gases that are dissolved into it, they tend to expand. And they form bubbles. And the force of the expanding bubbles can be high enough actually to tear apart the magma and just blast it into the air into billions of pieces, little fragments that we call volcanic ash.
And that, I guess, is where the problem comes from.
Yes, this can be bad news for aviation. Japan is at the intersection of two tectonic plates, the Eurasian plate and the Pacific plate. And the Pacific plate gets abducted, is forced to go down underneath the Eurasian plate, and is where basically you have a recycling of Earth crust and production of new magma. And this only means volcanoes.
So there's ash on these roofs, which must mean there was an eruption recently. How often does this thing go off?
Well, Sakurajima is probably the most active volcano in Japan, definitely one of the most active in the world.
Oh, cool.
And my colleagues monitor the volcano constantly, and they could count 50 eruptions per month.
50 a month?
Yes.
And why is ash such a problem for the aviation industry?
When the ash gets into the combustion chamber of the jet, it actually melts down in a very thick substance. It's a process that we know as sintering. And when this happens, it can cause the stalling of the engine.
Right, not good.
Now,
Right, look, if it goes, I want to be really close to it, so I brought this guy. Yeah. Let's get this thing flying. Just hold that, please, sir. Corrado, what does your research actually involve?
what we look at is specifically the physical processes of the fragmentation of the magma. So, for example, how much glass is in the ash. And glass is very important because the temperature of melting of glass is much lower than the temperature of operation of jet engines.
It's grumbling. Whoa! Oh!
Wave.
How big were those lumps? What do you call them, bombs?
Yes. So the ash is the tiny bits, and then over 6 centimeters, everything that is bigger is called bomb or blocks.
Oh my, they're huge!
That flew over a couple of 100 meters. Can you hear the thunders? This is produced by the electrification of the ash. It's producing flashes.
Lightning?
Yes. Volcanic lightning. The ash is self-charging, so you have ash emitted in the atmosphere and it rubs to each other and basically produce electrical discharges. We think that volcanic lightning actually sparked life on our planet.
What?
Yes.
So life on Earth could have begun from lightning in a volcano?
Yes, exactly.
That blows my mind. That is amazing.
Here it goes again. Amazing.
So research by volcanologists like Corrado have big implications on all our lives, from improving flight safety to discovering the origin of life. Mate, what a day.
I love this volcano.